The Bitcoin network, let's drill down into what it is at a fundamental level. Now we know Bitcoin is made up of these three elements. There is the network, there is the currency, which is transacted on that network, and then there is a record of those transactions. So we'll focus on the network because it's the most important piece. Without it, nothing else exists. And at a basic level, the network is just nodes all around the world that are connected via this common rule set, which is the Bitcoin protocol. They're connected in a peer-to-peer fashion. There's no central node that the network is dependent on. While there are a few different kinds of nodes, for the purpose of this video, we'll just focus on full nodes. There's no hierarchy between them. And when a node wishes to join the network, it does so voluntarily. It chooses which peers to connect to for the purpose of downloading Bitcoin's history, getting on the same page. And obviously nodes are free to leave when they please as well. So how do nodes all stay on the same page and operate without a central authority? Well, they're all running compatible software. Now, this is Bitcoin-specific software that lays out how the protocol works. The most popular implementation by far is called Bitcoin Core. You can actually go on GitHub and look at the repo yourself. If you're not technical, I would highly recommend you do this because it will help you see how Bitcoin Core is laid out. Now, full node, as we mentioned, runs Bitcoin-specific software. It maintains a complete history of Bitcoin, and it does that independent of other nodes. It's also validating Bitcoin's history for itself based on the rules laid out in the software. The third thing it does, amongst many, is enforce the network's rules, which is why it's impossible to get away with malicious behavior, because you will simply be cut off from the network. Looking at how many nodes exist around the world, while we don't know exactly how many nodes there are, we do know how many reachable nodes there are. Now, this snapshot was taken in December of 2023. There are almost 17,000. And we can see a breakdown by country as well. And what you'll notice is the most popular country is NA. So almost 11,000 nodes, or over 60% of all reachable nodes, we know are connecting via Tor. So there are two ways to get a node. The first being buying a pre-assembled node, so the plug-and-play option, or building one yourself. It's a very simple process because a node really just consists of two key components. The first being a very simple computer connected to a router and a hard drive for storing a copy of Bitcoin's history. Now, not everyone is going to have the means to run a node, but you should if you do, because otherwise you'll be using what is known as a light client. Now, a light client connects to a full node as a proxy, and that's how they interact with the Bitcoin network. It's obviously very convenient. You don't need as much storage space. So a lot of people do that via a smartphone. The problem is, and many light clients can connect to the same node simultaneously, you're outsourcing that verification and validation process that makes Bitcoin so attractive in the first place. You're not using Bitcoin in a sovereign way. So if you have the means to, you should certainly run your own node. Now we can see that networks over time, if they prove useful, can experience network effects. Here is a chart from Fidelity outlining some major innovations in history, or recent history. And we can see that with the addition of each marginal user, node, or mile of railway, or various innovations, the benefits to the existing network and the existing users increase disproportionately. Now, we did touch on some of the different dimensions that a network may have, different characteristics that are either desirable or undesirable, depending on what you're trying to achieve. Now, in the case of a monetary network that doesn't have a central authority, this is what Bitcoin looks like. Firstly, it's permissionless. Anyone can join the network and use the network. It's a very low barrier to entry. Secondly, it's dumb. It doesn't really care what is moving through the network, provided it just follows the rules of being valid. In terms of innovation, so how are changes proposed to the network? Well, it's open. We saw that from looking at Bitcoin's GitHub briefly, you can submit requests that maybe, if are popular enough, get merged. And finally, no central point of failure. Bitcoin is decentralized. Why is decentralization important? Well, firstly, redundancy and resilience, and secondly, censorship resistance. Reliability is very important in a monetary network. If you're going to choose a digital form of money, you're going to care about how dependable it is. If the settlement network, that is how transactions reach final settlement, you need to be sure that it's going to be operational when you need it. And I know Bitcoin is a bearer asset. There are ways to transfer Bitcoin offline and off-chain, but for global commerce, network uptime is critical. Now, Bitcoin can achieve this because there's no central point of failure, because it's decentralized. And miners are incentivized to keep producing blocks in tandem with a self-adjusting level of difficulty relative to the amount of competition. This is because they are compensated in Bitcoin, a highly saleable monetary good. So it's only because Bitcoin has monetary properties that Bitcoin is able to achieve such an incredible uptime. There are two concepts I want to touch on that maybe play into this. The first being anti-fragility, first coined by Nassim Taleb. And it's really important in the context of something like a censorship-resistant monetary network, because you have to think about the scale and scope of attacks from those who want to prevent or preserve the status quo and prevent something from Bitcoin like taking off. We're not just talking about corporations, we're also talking about nation-state level attacks. You can think of Medusa as the analogy when we think of anti-fragility. If you cut off one head and two grow in its place, well, the network's actively getting stronger from attacks. It's got an internal feedback mechanism that allows it to evolve. A way that we see this in Bitcoin is through its hash rate. Now, if you look at this chart, this is basically how much computational power around the world is being directed at the Bitcoin network. These are miners who are securing the network. And if you see that little dip around 2021, late 2020, that was when China announced it was going to ban mining. Now you can see that it had very little effect in the long term because Bitcoin aligns incentives, and you don't ban Bitcoin, you only ban yourself from the Bitcoin network. The next concept I want to touch on is Gall's law, and this is really just about system design. Now, if you're building a very critical system, such as a monetary network or a monetary system, you have to ensure that functionality and survivability is prioritized around everything else. Before you start making bells and whistles, you have to ensure it works and that it's indestructible. And Bitcoin is the world's first indestructible monetary network. This is a great analogy. So think of a single Jenga block basically supporting all the bells and whistles that other monetary networks might try to provide. The problem is, and this is just a basic engineering concept, look at the foundation. There is a reason we build skyscrapers with such deep and solid foundations. Last quote to wrap up, a great one from Parker Lewis, who wrote the Gradually Then Suddenly essay series. Quote, Bitcoin is too important to follow the Silicon Valley mantra of move fast and break things. Instead, it's move slowly and don't break anything. If a global financial system is to be built on a decentralized monetary system, the foundation must be protected at all costs. All right, we'll leave it there.